Hello, hello, hello. We should be going live right now. Just check the stream. Yeah, cool. So it seems we are live. Let me just open up. Okay, so I think we're live. I'm just going to wait. Just going to say stream starts in 5 minutes. Please don't give me any spoilers, problems. Okay, so okay, seems it's cool. What else we should open up the okay, that's cool. That's cool. I think the connection is all right. So yeah, I will open up this first. Where are the results to congratulate? Also, the official following the second day of the competition subsegment. No point. What? I have to read that. Following the conclusion of the second day of the competition, a subsequent General Assembly meeting, which conveyed on the outcomes and medal allocation, the scientific committee undertook a detailed examination of certain concerns raised by team leaders regarding the task spells. Spells is what? Like from the first or the second day? From the second day. During this scrutiny, it was discovered that some of the solutions submitted by participants during the competition had instances where a better result than all model solutions of the scientific committee was produced. Further investigation revealed that the fundamental premise underpinning the committee's model solutions was regrettably flawed. In addition, it was noted that the solutions submitted by contestants during the competition were also susceptible to counterexamples. Currently, no polynomial time solution is known for the task spells. In an effort to mitigate the impact of the oversight and uphold to the best extent possible, so the scientific committee suggests that recalculating the standings by excluding the task spells. So this is wow. So they really they really did one there. They really did. Oh, so okay. So the first place is Andrei Stefanov from Bulgaria, Simona Hristova from Bulgaria, and Luca Valentin, Muresan Luca Valentin from Romania. Well, congratulations on all. Um, the Macedonian team is here as well. Damian Davkov, Nikola Stoikovsky, Viktor Maximovsky, Vladimir Gerchev, and there's the unofficial teams here, the unofficial participants, Andrei Mladenovic and Blagoy Ranovsky-Stoyanovsky from Macedonia as well. So that's pretty interesting. Pretty interesting. I have to read now spells. It's just I mean, if a task on an Olympiad is flawed, I mean the I have to know what is this task, right? So yeah, cool. This is the official standings. Congratulations again to Andrei, Simona, and Muresan for the first three places, and all of them, all of the participants to try to solve the tasks. Okay, so let me bring up the tasks right now because we will want to. So let me bring it up here. Day 1 and day 2. So we know that the tasks in day 1 were these, and then the tasks in day 2. So I want to just take a look at spells because this was a task mentioned that it did not have any polynomial time solution. So the first step in achieving his goal is rendering all wizards powerless by destroying all spells stored in Hogwarts spellbook. To stop this from happening, Dumbledore will hide some spells in the following way. First, he takes the N spells from the book and creates a count I scrolls of the I spell. Then he finds M hiding spots. In the ith hiding spot, he hides size I unique scrolls. Now 2 scrolls of the same spell are allowed in the same hiding spot. It is guaranteed that the sum of them are equal. So some kind of a matching problem, I would assume. Dumbledore calls 2 hiding spots a safe pair. All spells hidden in the spot of smaller size. So what's the Dumbledore now wants to distribute to maximize safety. Okay, so finally he defines a safety as the maximum size of a safe group, and a group is a set of hiding spots such that any 2 spots of the group form a safe pair. I would assume they had some matching here or something. But 300 milliseconds, I mean, calls to hiding spots a safe pair. Calls to hiding spots a safe pair. All spells hidden in the spot of smaller size or equal size are also hidden in the other. So, so it's a subset essentially of the small is a subset of the big one. He also defines a safe group as a set of hiding spots such that any two spots form a safe pair, which means that there's like something increasing. That then like big number is the big set is the smallest set is always a subset of a large set of a larger set. Um, but yeah, I could see how this could go very wrong here, considering that. Hmm, interesting. Okay, okay, okay. Let's start with day one. Let's start with day one. Maybe we should. Yeah, let's start with day one. Maybe we should put on some music. Like I can't put music on streams due to the fact that I'm gonna get copyright claim, but well, I there are n by n measures initially empty. You perform n operations. Each operation can be the following two kinds: horizontal LRX. All the columns from this are set to value x, and vertical. After executing all operations, report how many times do. So there's some queries. And then how many times do the least and most frequent elements occur in the matrix? Uh, so you have like a query on the n goes up to this, which means I can't store the whole matrix. Hello, hello. Uh, so it means that I can't store the whole matrix, but the least and most frequent elements initially empty. What does it initially empty mean? Is it like 0? After executing all of the operations. So, okay, each operation could essentially. So you have like constraints and then you have subtasks. Okay, cool. So let me just think about this. Uh, okay, so one operation fills something, right? Some operation, like if there's some like this filled, then another operation can do this, and then it can go and then change all of these as well, and the other operations can change all of these as well. Now the element that is the least frequent element, so both of these elements will exist. Interesting, cool problem, very cool problem. Let's see this. So what if I start from the back and say the following? The back thing is going to equal to this, right? But subsequent things are going to subsequent things are going to. Somehow say, okay, So if I have already some things that are going to be last and I add some from behind, I need to see how many of these things intersect this guy here. And delete this from their score. Okay, so that's the most frequent. And also the least frequent as well. So I think that's the solution. Isn't that the solution? Okay, n goes up to 10, up to 1 million, which means that it means what is n? N is the matrix. M is the operation, so I can read that these operations. Each operation would set me off some this, and then I only need like a fanfic tree to query out, and probably that's it. Okay, let's solve this one. What could not determine the parser? Okay, let me just make a file. There's the Q queries, then I need to say the type of the query, type vertical, else it's horizontal, then I have LRNX, and so I will just do, actually, because I need the queries in okay, so we do this. Then for each query, we read that. Now we need to go back. Now we have to say, like, we have to do a fanfic tree. Doesn't need to be long at all. Save memory and faster calculations. Also, I can do tie here. So that's a fanfic tree. Also, I need to add a function get interval query is get fanfic tree at right minus yeah. I know that it is your favorite. It's my favorite, one of my favorite data structures as well. It's cool. It's very cool. But then what I need one fanfic tree for the vertical. I need fanfic tree for vertical, so forward the vertical and forward that's about n, and forward the horizontal also about n. Also I need the frequency, and the frequency would be like the frequency of like the elements, and the elements can go up to 100,000, but let's make it 10 to the 5, 2 to the 2 times 10 to the 5 or something. Then what you need to do? You need to query how many of these. Um, so like this, I will do like this. Type LRX queries at I. Alright, I can do that. Yes, I can do that. So if type is vertical, at the end of the day we want to add to the vertical side, we want to add at the index all cells in rows. I thought it was like this only. Well, that should supposed to be easier. I thought it was like okay, that's supposed to be easier. I thought it was just a segment somewhere. Okay, so you fill up the rows, which means that when you fill up the rows, you kind of can't access at all this, right? So you fill up these rows, then the thing is that if I have something here, so these are already filled, I want to say how many of these rows are filled here. But also if I have columns like this that are filled, I want to measure how many columns of this are filled. Oh, it's not easier. I think it's a bit difficult maybe. The intersection measures twice here. Let me just design some other thing here around this. Okay, so so this is easy, right? And then, okay, so the rows that are already filled, this is easy to get how many of them. But then you have to design like I mean, you're not supposed here to design the. You're supposed to. Well, that's even easier. Like you don't even need fanfic trees here. Like you can just pop off elements from some set or something. Just pop off the elements in the. So let's say we have two sets, one for the rows and one for the columns, and each set is like up to n, and here up to n. And then when I mark some rows, I'm going to pop these from the set, from this set. When I mark some columns, I'm going to pop them from the set. But now I have to know that, okay, I'm popping these from the set. So I know that these are full, but also some columns that are being popped from the set are something is twicely measured, right? So the twice measured is the amount of rows that are popped from the set times n plus amount of columns that are popped from the set times n times minus c times r. That should do it, I think. Okay. So I don't even need segment tree. I can just have to set appendix tree. I can have calls rows calls insert I rows insert I, and then the frequency is here, and then if it's vertical, what does that? Vertical means that all columns from this to that are set to that value. So the count of columns, we set C. When I'm putting vertical, it means that I have to delete these. So I go and I take a pointer. Well, IT is smaller or equal to R. Well, IT is not columns and IT is smaller than equal to R. So I have something to delete. C++. These are the columns that I will delete. Then zoom. You want zoom? Okay, probably this is fine. Tell me if this is fine. To remove element, right? So I delete all of these columns that I have not visited, and I know how many columns there are right now. Now the R can be calculated as n minus how many rows are left. So these are the rows that are being right, and now our frequency at x should be, we should add my equation that I've just wrote. R times n plus c times n minus r times c. I think that's it. And then the same thing should be created for should be for the other way around, but this is now rows. And this is again the same thing. Now here, this is commuted. I'm just going to change this calls to, so these are rows, 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 calls are these. All the other things should be fine. Now the least frequency, so what do I need to output? I need to output contains the frequency of the element that appears least often and the frequency most often after k operations. So if frequency of, so I need to go to this. If frequency of I is small, small is if frequency big I is I think now the small here minus 1 big minus 1 small id, no, the small should be int max int min small minus 1 big minus 1 and then small id and big id. I think that's, maybe we have some bugs, but we'll fix them. I'm just worried that set is too slow. Like the milliseconds are really tight here. I don't know what is going on here. Wait, why is 10 and 7? What is 10? What is 10 and 7? What should I print? I'll put it. The frequency of the element that appears least often. The frequency of the element, not what element. Okay, let's see the frequency of the element. Let's see here. To remove, so we have all of these columns and minus row sizes. So first goes 3 and 4. Columns to remove plus plus, but now here is vertical. Push back erase element in that row. Then the rows are, so is my equation not right? Well, we add all of these rows, the columns times n, plus wait, we add for the rows Now there are some columns that we need to kind of delete, and these are the columns that we have already used. Columns that are already used times the amount of rows that we need to do. So this is the columns times rows that are already used. Maybe it's this equation. Okay, now we get it. Wait, I have to log in? Wait, what? Ah, please don't joke with me. Hello, Victor. Please don't joke with me. What is this now? Sign up, don't set country. Okay, this I will change. uh, wait, what? Please. Come on. Can you be more... Wait, I have to check my email. There's nothing on my email. I don't think this works. Authenticate to use the workspace. Wait. Can I submit like in practice or something? Like maybe this is virtual participant. Wait. Which means I cannot submit anything. No, this is bad if I can't submit anything right now. Please. Can some of you guys in the chat submit something? Like does it have some access that you can send me? Like I want to just try the problems. Like I understand it like on the scoreboard, but I mean, come on. Okay, we solved the first one. Let's go to the second one. I'm not gonna lose some time here. I don't know if you have guys like submission, like if you guys have authorization, it would be really nice if you can send something. Okay, a group of end wizards must join forces to fight the force of evil. The ith wizard resides on the real line. The coordinate xi has EI units of experience accumulated from their previous magical encounters. The coordinates of the wizards are pairwise distinct. To join forces, wizards must share their experience with each other. The ith wizard will choose another wizard that is not himself as a mentor. Chooses jth wizard to be a mentor. The ith wizard will gain this is like the experience accumulated divided by the different. Okay, so you want to choose wizards that are really close together, right? Know that wizards cannot choose mentor themselves. Compute for each wizard the maximum experience they can gain by choosing the best mentor. Note that the wizard can be a mentor of multiple other wizards. Wait, so you want to minimize the distance, right? Oh, but also this is EJ. Oh, okay. So you want to minimize distance, but also maximize this. Okay. So there's like okay. So there's the each mentor, each of these has some experience, like right, EJ. Uh, this kind of if I'm here, I kind of div. So if I go, so I kind of fall. How how does this function look like? Does it look like this? It looks like this, isn't it? So the most optimal things are like if I'm here, what I want to do is I have all the points that are to the right of me. I want to evaluate them. So I just do like a convex hull of like all of these things. It's not like a convex hull, but like it's an evaluation of all of these. Mm, but if you are if the point is left to me, I will do the evaluation on the other side. So you kind of build just a convex hull structure. But like if I have a point that overtakes this guy, if I have a point that overtakes this guy, then like I will just pop this guy off. But if I have a point here that like has some time to overtake it, then like time to overtake it is like after this. So I built like just a convex hull structure. I think. Okay. I mean, that's a cool problem. It's a very cool problem. Let me see X orbs. So if I see the scoreboard, if I cheat and see the scoreboard, no one wrote the convex hull. Or yeah, there was one unofficially, Dino Hadjic, that wrote the hull. But then, so most people tried this X orbs. Okay, let's see what this is about. Maybe we'll try to write them, try the whole afterwards. In Minecraft, for every task completed, the player is rewarded with a certain number of experience points in the form of green orbs, each orb rewarding the player with different amount of experience based on its size. XPI, an orb of size I rewards the player with XPI experience points, where XP is defined as follows. XP1 is 1, XPI, so what I starts from 2, is the previous prime. Oh, hello, Blogger. I was wondering about. So, Blogger was on this Olympiad. I was wondering about. So, I solved task 1 from day 1. But I was wondering about how can I submit the tasks because I was given access like to this sepi.cs academy thing, but I cannot sign in, nor I can sign up. Great. Let me try again. No, it just says signing up, but you can do a virtual. I mean, I cannot sign in. You, like when I say register for a virtual user not authenticated, and then I don't know. You're not allowed to register to this contest. Yeah, well, I mean, I don't know why did they limit it? Like, why can't I just play it as a practice, right? Like many times I've solved things here on CS Academy, and then like I could just submit it as a practice. Oh, can you give me like the login details or no? Wait, no. Okay, don't give me the login details. Right, I can send the code. Here you go. But I can't debug it, so I mean, the trick is that I'm gonna keep sending you codes. I don't know if this will ever gonna pass, right? I mean, it should pass, but no idea. Errors. Oh, there's the missing. Wait, how did the no? There's no error. Oh, there's errors because I did not send it. Oh, I sent it in Discord without the code thingy. Discord converted the stars here into like italic or something. That's why it changed. Okay, it doesn't really matter. Okay, so magic we know that it's a convex hull. Okay, so I want to see this one here. Previous prime, 76 points on the first one. So I got 76 points. Blogger says. Uh, okay, let me see what was the. So do I need to optimize it? Do I really need to optimize it? Yeah, I really need to optimize it. I'm just gonna show the Okay, 76 points. Wait. It means that the scores, I don't know how they're scored over there. Okay, so I need to optimize it. Let's see how. The scores, wait. So, wait, I'm pulling off chunks here, right? When I'm pulling off chunks, these chunks are pretty much continuous. So I can pull off. I mean, one can use some linked list with jumps, but that's too complicated. These are continuous jumps. I don't know what. It shouldn't take that much second. I mean, one thing I can optimize is this, of course, but that hardly matters. That's one linear. Wait, that should be long min, and that should be. Wait, I don't know how this. That should be long max, and that could be here. Is it possible to get the is it possible to get the credentials so I don't send you all the time the code and then like I can test it here and see what. So here I can do like a vector to remove, and I can just say that this is. Then I can use some pointer here to not push, because pushing inside that vector is very intensive. But I think p0. IT, then well, if I don't use a set, I would need to remove them from like the. Yeah, I know that this one wrong answer because I saw that here I didn't have a long max, so it I know. So this will remove that, and this should remove the calls. But if I don't use a set, well, I can use a. Well, that's insane. That's insane. That's insane what I thought of. Like DSU? Ah, that's insane. Really, but how do you? That's insane. If that's if that's the solution they want, still my solution is very fast. But if that's the solution they want, ah, wait. How do you binary search? So like you go to some element, okay, this element points to some other element. So you just don't binary search, you just have like a DSU and then like each point where the oh, is that the solution they want? Oh, okay, can I send you this code to see if like at least so I will be just sending codes back and forth, but at least okay, if that's the solution they want, okay, that's insane. That's insane. There's a technique called DSU with jumping. So uh, what you do is like you have a DSU. So in our case, you have two DSUs, 80 points. So okay, so we got 80 points. We got 80 points. Um, but then uh, I have to do better. I have to do better. And that's the DSU with jumping. I think that's the only technique I can think of that will optimize this. Okay, so we need still to count something, right? Now we don't need this. So we got 80 points. Okay, whatever. We will do this. Let me create a function here, and I will say update. This will accept a DSU. Okay, so I already know what element is am I do I want. Just the jumping step here will be made. I have to be careful here, and that's I can't use the sorting method. I have to do um, parent. But I will compress it. So I will compress it, but I won't use this. So if it's A, it's A. I think that was the DSU jumping, right? So if the parent face A, then we return, otherwise we compress it, we find both parents, we set the parent to one of the parents to Y. Now to update, we have to go. We have to go to the L point, DSU find set of L. Now the idea is that, wait, you didn't save the credentials? That's no problem. Are instructs slower. I'm allocating memory, so it shouldn't be slower actually. It should be fine. It should be very, very fast. But I think the idea behind the problem is to use DSU with jumps. This way it's like extremely fast. So okay, so I have some things, right? When I land at some point, this point may point to something else already. I will go there. So I will do maybe some while loop here. So while true, if L already points above R, I'm just going to quit. If it points inside R, so it like points itself or it points to something else. So there's two ideas. It points to something else. Then we kind of want to go there, right? So that should be one is enough. Don't know if you mentioned, but you should be able to solve this problem with lazy segment trees. How am I able to solve this? I mean, yeah, maybe. Yeah, okay, with lazy segment tree should be solvable as well, right? Just so apparently sets are slow. With lazy segment tree should be, yeah. That's a cool observation. That's a cool observation. But let's write it with the. Should we write? Yeah, I mean, it's interesting to write it with the DSU with jumping, right? Or should that be slow? That may be slow as well due to the compression. DSU is, I think DSU is in the syllabus, so should be as well. Yeah, right. But I'm thinking about if it's slow with the compression at all. With the lazy segment tree, what you do is you pick up the. You want to have a segment tree where you want to update some interval, set them all to 1, and then it queried some interval whether or not you have. Oh, that's a way. I didn't think of lazy segment tree as exactly, but that's a really simpler solution because it doesn't require anything to do with n. I mean, it requires within log time. So my solution is amortized with an amortized complexity, right? Like, but there's log as well in the amortization here. Should I solve it with or should we solve it both ways? Maybe with a segment tree and a DSU. Okay, so for a DSU, what do we need? So we need to, when we're iterating over, we're just going to point, we're just going to point everything to the, everything can be pointed to the R here. Okay, so what if R is somewhere else? Well, we find the set where R is. Let me point that. So everything should be pointed to R. Okay. I think it's fine even with the DSU. It should be fast enough to to write. I mean, to pass everything. So the idea is this. Uh, okay, let's do a while here. While from the left side. I mean, with the for loop. I'm not sure what. So I get this. If this point's already against R, I'm just going to leave. There's some count. If this doesn't point, so this points something somewhere here, means this is the last. There's some edge cases here a little bit, but whatever, we'll fix them. So if I'm at some point, I need to know whether or not something points to it. Whether or not this is visited, this is deleted. If it's deleted, I will go to the next one and just make it jump. So like I'll have like another vector deleted. If deleted at I, then I'll say DSU merge DSU merge I and I plus 1. Now the DSUs, we never defined them. The DSUs should be DSU vertical has 1 million, DSU horizontal 1 million. So if it's deleted this, and then I is going to be find DSU find set of I plus 1. Deleted. continue. If it's not deleted, it means that I'm going to delete it right now. Deleted dice true. C++ DSU merge I and I plus 1. And then I plus plus. Or no, I plus plus, but I's DSU find set of I plus 1. Okay, so I think that's it. Now here update is going to take in LR and then DSU vertical. Also delete, it should be, one should be vertical, one should be horizontal as well. Now how many are deleted here? Int dv dh d plus plus dv, how many of them are deleted, how many of them are deleted. So this is the columns, deleted the column, so this is dv, this is dh. I think that should pass. Okay, that passes the test. Okay, blog again, I will send you code. Oh, the message is too long. Okay, upload as a file. What? What's the... I feel like the time the time when you had to show your teacher the code and then like you needed to like send the code over. Yeah. Okay, it doesn't really matter. Like it doesn't really matter. So like if a segment tree solution works for this problem, then we could just call that for a segment tree. Oh, runtime error. Okay, I don't. I'm overflowing something. The here maybe should add plus 10. I'm not sure. Like you don't have the credentials. I don't know. Like maybe like try adding here plus 10 on both. Yeah, thanks for the images. Love, send some images over. Maybe here adding plus 10 blogger maybe. I'm not sure. Runtime error. Merge function. Oh, you don't well, I don't need to return. I just make it void. Oh, and also it was just a merge function. But wait, what did it score? Oh, we got okay. Yeah, nice. Okay, cool. Cool. Let me just show you. Cool. I will just open it maybe in browser. So. Okay, cool. Okay, that was. I mean, 67 milliseconds. The DSC is very fast. You need to admit that that is not possible with the lazy segment tree. However, like you call it, I mean, it's possible, but like that's fast. That's fast. That's very fast because after some queries, there will be like in constant time you will be answering queries. So okay, okay, we solved one. That's important. Now, do we get a medal? Probably not, but okay. So we know that this is some convex hull. This has to be some convex hull. Let me just read this problem. Did you remember the password or is it stayed logged in? Just stayed logged in. Okay, it doesn't matter. It doesn't matter. It doesn't matter. Previous prime 2 times x minus 1, so some recursive formula where previous prime is the largest prime number that is smaller than or equal to a. Okay. For okay, so the numbers go up to 10 to the 12. For instance, the first 8 size of orbs reward the player with. Okay. Notch the creator of Minecraft made it so that yeah, don't worry, Victor. It's fine. I mean, as long as we have someone that is state that has the pass logged in, I can send the blogger. Then he will judge it. Made it as so the creator, the Notch is the creator, but he's not on the team of developers on Minecraft, right? Yeah, blog is someone on the inside. Is Notch on the developer team of Minecraft? Made it so that any non-negative integer number of experience points that can be broken down as a sum of experience rewarded by orbs in the following way here concatenation. Any non-negative integer? Yeah, he sold it to Microsoft. I know. I'm not that old to not know that, but I know that he sold it. I'm just wondering if maybe he's doing something with it. Broken down as so he made it so that any non-negative integer number of experience can be broken down as a sum of experience rewarded by orbs. Okay. So the array decomposition of A experience points. Dec 0 is an empty array. Dec A is the XP max concatenated with this. Where okay, it's the largest element in XP such that it's smaller than that. All right. So the previous prime here, because 2 times x. So how? Okay, so if we calculate the previous prime, then this decomposition is in logarithmic time, if I am not mistaken. He also defined count A to be the length of the array dec A. Therefore, count is 3. It wants to know the answer to queries in the form of LR. Find the sum of L divided by the count of L. Okay, I already see where this is going. Count here is definitely going to be monotonically increasing, right? So there will be like count of 1, count of 2, count of 3, count of 4. Then there's some of these that are going to be like up there, right? So essentially, because count is monotonically increasing and it's up to some logarithm of this number here, we can divide the arrays up to that count. So we can so first you have count 1, then count 2. So first is like, count 1, count 2, count 3, count 4, count 6, 5, and whatever. Some numbers represent from L to R this count. Now, if I have from some query from this point to this point, I want to get this count, I want to get this, and I want to get this. There would be at most logarithmic different steps where this changes. This count changes. Then, so what number it is, every number can be, so I want the sum from numbers from L to R, so sum from IL to R of I divided by, so this is divided by the count at position L. So this is L and R. This is query L and query R. This is different. So I want this, but of course this will be here changed with the query L and R. So this will be like minimum of R and RQ, maximum of L and LQ, something like that. Blah blah blah. This is okay. So how do we calculate? So I need to calculate where this changes, where this count changes, where this count occurs here. This is important. This is very important to calculate where this changes. I can simulate. Can I simulate it? Oh, actually, scratch that. Not sure that this is monotonic. Actually, let's do some simulations. I'm not sure what is this. I'm not sure if it's monotonic or if it's not. I mean, it shouldn't. Now that I think, it shouldn't be monotonic, but it should be very close to monotonic. Okay, let's do some simulations. Let's find the previous prime numbers. Let's find the XPIs. You guys said I need to zoom in. Wait. Oh. That's fine. So first we start from 1, right? Then start from 1. Then for like 60 iterations, new x is x times 2. Now I need to find the previous prime, which means that I need to kind of go down from new x until 0. So we already have few computed, right? The first 8 are computed. What is this now? 5, 6, 7. If so, I need to square root of j. So I'm saying if something divides k, if something divides j, then that's not prime. If it's a prime, then new x is just going to be j, and I'm going to break. So I at the end of this, I should have all of these calculated, and they should be what is this, 10 to the 9. This is, but we need more. We need more than that. Wait. Wait, something's wrong here. Oh, this is wrong. Something's wrong. Of course, this should be L. I do have integer. God's quit. 60 should be way enough. Yeah. This is way more than 12 digits. Yeah, this is way more than 12 digits. 12 digits and somewhere here. So we kind of have these numbers, okay. Where is 12 digits? Where does it end here? 10 to the 12, right? 10 to the 12. What is this? 9. We can call it a day here, right? Oops, let's print this. I think we can call it a day here. It should be 41 numbers, whatever it says. I mean, I don't know if there are 41 now. I mean, that's 12 digits, right? Well, there's 6, 9. Yeah, that's more than 12 digits. So it doesn't really matter. Whatever. What it matters is that somehow. Okay, so this is computed, right? So somehow now I want to see how this changes. So for each number, I will compute how many of these. So of course, I can't compute for each number, but I just want to simulate it for small numbers to see the count, how the count rises. Let me do up to 50. Uh, okay, this is bad. Yeah, of course. But after some time, interesting. Very interesting. So the count is one of these 40 values, right? And now we need to find the sum of all these counts. find the sum of all these counts. The subtasks are up to 10 to the 8. So up to 10 to the 8, you can probably pre-compute what is the count for each of these, and then use some kind of okay, 10 to the 8 is easy. 10 to the 8 is easy. I mean, 10 to the 8 in memory, we can put it in memory. It would be 10 to the 8 times 40 times 10 to the 8 times 40 times 4. Okay, that's not easy. That's not storeable. That's not storeable anymore. The sum of these numbers, I don't know what they represent. What is this? So they're all primes, but they're weird primes. So you need, wait, if they're all primes, you need prime factorization only on them, right? Isn't this correct? So we can't, not prime factorization. We have some prime to the 8th power. Not to the 8th power, but a times this prime, then the sum of all of these. So each prime has some coefficient. And now you want okay. So I would guess that my guess is that you kind of do it somehow backwards. Well, numbers that are, so if I have some number here, some big number. So what is the biggest prime? It's something else here that minus this something. I gain some other thing. Doesn't really matter. So I have this. The count to get to that point is essentially the count to get to that point plus 1, right? So we have dp of I is dp of, so of u of I minus xp of u of I, whatever the upper bound of I, this xp plus 1 So, but the queries are queries up to 10 to the 4, 50,000 queries. Each query I can take some time in each query. I can take some time. How do I say what is the count of? So I want to solve the following question. How many numbers up to L have count equal K? I want to solve this question. How many numbers up to L have count equal to K? If I solve this, it's easy. Okay, so if I solve this question, how do I solve this question? Let me just check the stream. Nice. So for those who tuning in, we are actually solving problems from the JBoy 2023 from day one. We solved one problem. This is the first problem, frequencies, completely. Magic, we know that it's some kind of a convex hull, which is very interesting. I may code it later, but now I'm kind of interested in this problem, XP orbs. It's a number theory problem, and I have to solve here some question. The problems, I will give them in chat here. This is like if I go here, I will give them probably in chat just for if you want to read them. So how do I solve this? Well, have count equal to K. So to have a count equal to K, we have to look at when does the count kind of rises and falls. This is important. Wait, there's 64, right? 64 can be represented with how many bits? 64 can be represented with 6 bits, right? Well, I'm thinking the following idea. If I take a look at one number that is x plus some prime from our case pi plus some pi plus some pi. If this pi is already in x, let's say that x is divisible by pi. If this is correct, then all of these numbers are also having the count of x. So the count of inside of x here, this is also true. Okay. So this is also true. Can we make like I'm thinking of a sieve, but a sieve will only work up to the memory member. This would be a sieve, something like a sieve. You have here some you fill up these numbers. But no, this doesn't have the count of 5. This has count of 5 plus 1. No, this is, I mean the count, oh yeah. No, I thought about the count of primes, of unique primes. It stays the same. But this count increases. Oh. I don't know how is this. I mean, maybe for some small subtask here, this is doable. This again, not sure. I mean, it's probably doable just up to 10 to the 7 or 10 to like if you are doing something. But 10 to the 8, yeah, I mean, maybe doable. I don't know. But I mean, 17 points only for no constraints. It's not worth that much. I mean, is it? I want to see the results. Has anyone solved 100 out of 100? No. The most they got is 83 points. That's probably that's both of these. I'm not sure how you're supposed to solve this for 100 out of 100. I mean, I could write something for subtask 2. You could pre-compute everything up to some point and then, I mean, easily you could have something like this. You could easily have something like this, and then you could say that up to some maximum number Let me just so let's just try to see how many points we'll get with something like this. Count at I. These are our counts, and then for this is our pre-computation, and then for our queries, I'll just do this. When I heard the solution to this problem, my mind was blown. Well, I don't know. I'll just see out 0. I'll try to think a bit about it more. Let me do modular integer. Let me take this. I think that should be fine. Okay, so the idea is that the answer is ask it R minus if L is if L is positive, ask it L minus 1, otherwise 0. And the answer is this is okay. I have to iterate over the exercise. This is I need the count, but I also need I need the sum, not the count. Do I need the count as well? I kind of need the count and the sum, right? At this count, I will add to the sum. I will add to the I, right? And then here it's like first the sum is sum of R of U, or U R, I think this is the other way around, J I minus 1. That should do it, right? And then you do sum, and then sum of so sum at U at R minus sum at U at L minus 1. And the count is the same. And then answer is sum over count. See how that's. If this is totally different, I don't know how I even debug this. Oh, does it take so much time to compute? Oh, the sum should be added. Oh, so why so much time? Instead of upper bound, I will do this. Okay, okay, well, uh, I'm trying to just simulate this brute force for task 3 to see how many points I will get. It's not really brute force, it's just pre-computation. Count, see, this is the count. Where's my mistake? Am I calculating something wrong? The first query, um, what am I calculating wrong here? R what am I calculating? X, right, t divided by x modulo. Oh, that's correct. I mean here if that is correct. What is the sum and the count here? The sum is 2, 12 over 2. One, two, three, four, five. 1, 2. 1, 2, 3, 4, 5. 1, 2. 1. One of these, two of these. Oh, not the count. I mean, not the. I don't care about the. I care about this. Wait, no, I care about the count. The count is this. The count is this, and then the sum of this 12. $45, 11. That's not 11. That's not 11. How's that 11? No, that's 11. That's 11. That's 11, and that's 45. Okay, that's correct. 11 divided by 3 plus. That is correct. 11 divided by 3 divided by the count. The count is u. I'll need the count of these. I mean, that seems correct. That seems correct. Let's see in this how fast is the how fast are the pre-computation? Should be very fast. Should be okay. I'll send it while your way to just. Why doesn't give it? Why it's too long? It's too long. How it's too long? Come on. Got it. Blogger says gonna add pragma optimization if it doesn't pass. I mean, I don't even know pragma optimizations. I mean, it shouldn't pass all of the test cases, right? I limited, but I was wondering, like, with something like this, with some solution like this, how far would it get me? How far points would it get me? Because, like, if I take a look, I mean, magic here, it's solvable convex hull. I think it's solvable. Like, you just have to binary search. You would have some segments where runtime error, it says 0 points. Well, probably they have limited the test cases that I would guess that they don't allow for partial points here or something. But RE, that doesn't make sense. It shouldn't. That shouldn't happen. That should not happen. Oh, memory. Vectors could be very heavy. I mean, I can delete this count vector. I don't need this count vector. I just need the sum, right? So, the count vector doesn't quite do anything. This, but this shouldn't be memory intensive. I mean, how much memory do we have? 512. I don't know. Maybe limiting this here. It's not. Oh, something out of bounds, says Blogger. Something out of bounds. Well, here. That is out of bounds. And here. I mean, here, no. Here is fine. Now it should be fine. I mean, I need to send it on. Try now. I have no idea. That was out of bounds. I don't know how the. But the sum only changes, but it changes by some I, right? And this sum we have to. Maybe what you have to do is, it says wrong answer. But do you get points? I mean, yes, it's wrong answer, but considering 10 to the 8, it's uh, probably you have to push here up to 10 to the 8. But pushing here up to 10 to the 8 will result in memory. I'm sure will result in memory. What is this? This 10 to the 8. Yeah, it's grouped cases. Yeah. I suppose. Try getting up the maximum a little bit up. There are some correct ones. I mean, yeah, of course there are some correct ones. It's a correct solution, but it's not. Try making it up to 10 to the 8 here, but it would, I guess, memory exceed. I would guess so, right? But okay, this is fully mathematical, so this is fully number theoretic thing here. I would. I don't know what I would do. I'm not sure. Like how to answer this question. No, not how many numbers. While we are interested in the sum of numbers, we're interested in the sum of numbers up to L that have count k. Yeah, memory limit exceeded. If you go up to 10 to the 8 like this, it will memory limit exceed. Hmm. All of these primes, do they have something in common? I mean, all of these are prime, so I need some kind of decomposition that will get me the. Count always increases by 1. I'm not sure how they. Wait, I know. Like the count is not up to X. That's the problem. That's why it has some wrong answers. Like the count can be really high. I mean, can it? No, it can't be really high. It can't be up to X. X plus something. Hmm. Interesting. Okay, before we go maybe on problem 2, I kind of want to see the problems from the other day as well. Okay, spells, we know that problem we won't touch it because it probably doesn't have, so they said that doesn't have a polynomial solution. So we're not going to even touch that problem. Tractor is what? Tractor is a problem that a lot of people solved. I'm just interested in. The first stack contains n bales, where the first bale is at the bottom, the nth bale is at the top. as weight AI. The second stack M bales, the same idea. You want to transport N plus M bales to the processing plant using a tractor with a total limit of W. In one trip you may load bales from both stacks, but the bale cannot be loaded before the bales on the top have been loaded. The total weight of the bales loaded into the tractor on each trip must not exceed W. Determine the minimum number of trips. Some kind of a DP problem. Blogger said that he solved it really quickly, so I would just assume DP, right? I mean, if the bales are already loaded, it's kind of saying that okay, you have some table n by n, and then you start, okay, you have all of the bales here. If I want to get to this bale, I need to get this bale, but there's a load limit W. Load limit W. Is it a DP? I mean, it has to be a DP, right? How many bales you will load? For each position in the DP, you will load something. So, like, okay, so you want to get to this position as this the last M and the last, I mean not the, but like I and J, right? And so I can load some of these and I can load some of these. So in here I have some limit that I can reach. So the sum of these and the sum of these, and then what is my cost to reaching at this position? DP at this position, DP I and J, is the minimum over all I or all K bigger than I, all L bigger than J, such that dp of K L plus now I load this and load that plus this plus the sum of weights. So there are two sums from AI BI. There are these two sums here. Interesting. So that's the equation. I mean, sum here from whatever, that doesn't really matter. This is something else. N G G. I don't know which letter it is. But this is the sum, and then this is the sum. Now there's another DP, and that DP is like DPI J, and then like weight. Weight is a very strong dimension. I mean, weight can be compressed, right? Not compressed, but stored sparsely. If it's stored sparsely, then maybe kind of propagate it, so like it's like amortized. Wait, what about binary search over the answer? Is it possible to go with this many number of trips? Because it's monotonic, the answer is monotonic. So let's say that we have some k trips that we want to go, and then we say that what do we say? Okay, for these k trips, I have to transport the goods somehow. So I have now I need to optimally transport the goods. What is the most optimal way to do this? Interesting. Not sure. Let's have them ordered like this. And now these are the goods. AI PI. So we start like this, and we say there's some sum. Let's say from here and here, there's some sum. It's still possible. Then Oh, this is better representation, I think, with the table here. So you have I and j, right? And then you can sum them up. This is possible if and only if the sum of I and the sum of j here does not exceed our weight. So there's like so it's something like this. So something like this. And if this is possible, if somewhere here is possible, then this is possible as well. If some here it's possible with some w, then this is w minus 1. Wait, this should be an easy problem. This should be an easy problem. It's only 200 milliseconds. Wait, I will start for this for every position in J. Wait, this is an easy. Okay, I see. I think I see what's the idea. I start from taking some J's at this position. Then I say, okay, what if I don't take this J? But with this, I may be able to take some I. And then I do this. But this is still n times m times n, isn't it? I mean, don't overthink it. How I'm supposed to know? It's weird. It has to be something with a binary search. You need n times m time complexity. Just n times m without any binary search. Yeah, because 200 milliseconds. Yeah, 200 milliseconds. So it has to be like a table walk, I think. N times m time complexity. Well, if I don't add one, so let's say just an ordinary DP, right? Like, okay, so I'm at some position I and I'm position J. I can add this with my trailer. I can add this with my trailer. So for this, I keep the minimum DP and the weight that this DP is going to, like the weight that remains. Then here in this thing, I will have, okay, I can include this if the weight is smaller, and then, okay, I think I can solve it like that. I think. Sure. That should be it. I just keep the weight and the count of these tours that have been made. Then start from the bottom and do another thing. Let's try. I think that should be fine. Am I mistaken somewhere? I mean, that's optimal. I think that's optimal. I think that's optimal. So the DP will be like and the weight will be it lags because I'm streaming, so I don't know what I'm typing. So I start from the position, from the last position. I kind of want to have more room for everything here. I kind of start from the last position. So dpij will be, if this is the last not taken, what is the cost if this is the last not taken? So dp of so dp of I of j plus 1 have some count, right? Some count that this would go, and then there's if I take this means that I take j plus 1. Yes. So this means that I take j plus 1. So if I take j plus 1, then there's int take j is what is left is this. If take j is bigger than a and j, bigger or equal, then I can take, then the take j minus this is whatever it is left, and the dp of I and j should be so there's the dp of I and j plus 1, and then the weight at this is what is left if I take j right now. If this is smaller, then you can have dp of I and j plus 1, and then this is w minus what is a of j, because I will start a new journey. And this is the same for if I take the left, the right, the other element. So it's either I start a new journey or it's either I take. But we always want to minimize, or do we? Know how to prove that. dpij plus 1. That's top. So it's either this or that. And then for the other side as well. Take I is what is left is take I minus b of I. Now take I here is fine. Here it's fine. Now this zoom-in function, kinda not sure if that's optimal there. If new dp, new weight. If new dp is smaller than our current dp, so our current dp, first we have to set it. If new dp is smaller than Now the weight is W. That should work. Only one example? Well, this is NM, this is NM. Weight J plus 1 here, plus 1, plus 1, plus 1, plus 1, plus 1. I need to see the DP table. I will. Minimum is j plus 1. J plus 1 is the DP. What is left? This is 10, 10. All these weights are 10, 10. And then I want to get this. Is this minus that? 4 minus 4 You kind of have to do this probably, right? Oh no, my head hurts anymore. Hello, hello. We are solving, taking a look at problems from the J-Boy. So, okay, this is the last problem. We're going to take a look. Just okay. So I mean, I can fix this DP, or maybe think of some other type of DP. So we went through all of the problems. I don't want the live stream to take more than probably 4 hours, because I'm tired already. So I mean, one of the problems was taken away from boy. So kind of interesting thing there. N by n of the following types. Rope is maximal connected sequence of segments occurring in the tiling. A rope is highlighted in the red. We assume that the two. Oh, so you can have like the. You can have it like this. Wow. A rope length is defined by the number of segments it contains. You're asked to compute the number of V-shaped length two ropes with extremities on the edge of the board. Moreover, compute the number of rhombuses, which are defined as length 4 ropes that do not have extremities at the edge of the board. Compute the... Wait, you have to do all of that? Wait, what? Compute the length of the longest rope that starts on the edge of the board. For instance, the rope highlighted in the end starts at compute the length of the rope that starts at, for instance. Okay, change the type of exactly one tile such that the length of the longest rope with extremities on the edge of the board is maximized. Also compute the number of ways this can be done to maximize this length. It is guaranteed that a way to change a tile that leads to a longer maximum rope length exists. Compute the number of ways this can be. So there's n. There's n up to 2000. So what is this? Depending on the value of p, output the following. So there's p in the input. Output two integers. So you can actually solve any of this, or solve. There are 10 tests where p is 2 and 10 test cases where p is 3. the values of n on these test cases. Scored individual. Okay, so you kind of want to probably brute force. This is an implementational problem that I'm guessing inserts will be something. I mean, some kind of implementational problem like this one can be given. Okay, so the tiles, what are the difference between tile type 1 and tile type 2? Just the rotation, right? So the rotation is the difference. The ropes. So if I imagine it as a graph, right? Like you can imagine it as a graph where nodes will be like these points here. And this would connect these two nodes. This would connect these two nodes. This like that. And now the question is, how do I find the maximum rope? Well, for each of these here, I want to wait. Can a rope be like? Can a rope be like this? Or wait, what does it mean to be a rope? Again, a rope is maximal connected sequence of segments occurring in the tile. A rope is highlighted above in the red. We assume that segments do not touch. A rope like this defines the number of segments. Thus, the rope highlighted in the red has 16 segments. Note that segments from a type 3 from this count same as segments from type 1, type 2, even though they're geometrically longer. Yeah, I mean, yes, but like, for example, uh, for example, if I have, okay, I have these tiles, right? Let's say I have a tile like this, and let's say that I have a tile like it doesn't really matter, but let's say that this tile is at the end right here, or right here. Then I have something like this. I have something like this. Then I have something like this. Can this, my question is, can this be considered as a rope? Like imagine like all the tiles, like this is just the board. Like imagine that all these tiles don't exist. Like the board is like this. Can this be a rope? Really, it can't be. It can't be a rope like this. I mean, there's no example of this happening here. So our board is actually what, made of 3, 3, and this is 2, 2. So like this board. Well, if this is a rope, then this is like, oh, it's stupid, you know, like. Well, okay, start from anywhere and just like do maybe some kind of like a BFS or something like push DP. Like I mean, start from the point, and then the thing messed me up was the loops. Yeah, Yeah. I mean, you have to know where you have entered and where you have to exit, right? I mean, what is the easiest subtask of these? Like P1 is what? Is P1 is just counting these here. This is kind of easy, right? So this is just like getting on the edge of the board and seeing if there are two types of like these tiles and getting like in the center where these tiles occur. There's so this is kind of a very easy subtask, right? This is solvable. Everyone should solve this. P2 is this harder thing here with the compute. What is P2? No. P2 output the length of the longest row. So this is the length of the longest row. So if I have the length of the longest rope in a linear time, I mean not a linear. I won't have it at a linear time. I would have it in a. Then I have to know, like, I would assume that for P3 you would have to have like a data structure where changing something, some tile, flipping some tile, you can like quickly say some about the length. For that, you could probably get some points using recursive. But what about like some DSU? I mean, isn't it? I mean, not DSU, but this third tile is making the problem. If every tile is type 1 and type 2, then it's easy, right? Because there won't be any intersections. You can't create intersections with these two tiles, however you look, however you want. But then this third style uh, is very problematic. Yes, I mean it's still there could be interesting things, something, but like like you see here, there's no intersections. This guy is problem. This guy's problem. This guy's problem. So only in these intersections do we need to keep something. Uh, but are you sure that this is even possible? What I said with making the rope like that, that's not possible. And I think like I'm not sure if like this is possible here. That's how they explain the problem. I mean, here it doesn't say like it says a rope's length is defined as the number of segments it contains. The rope highlighted in light contains 16 segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Note that segments from type 3 count as the same segments from type 1 or type 2, even though they're geometrically longer, but that does not tell me anything about. I doubt that's possible. I just doubt that's possible. because that would include like a node here in the middle. So like you can go from here or from here. So now for that cell you have to really remember where you have entered and where you have left. So for each cell you kind of have to remember where you have entered and where you have left. And then if you go here, if you enter at some cell and leave at some other cell, so you maybe like a DP where like what is the, so you start from this point and what is the segments that I'm visiting when ending at some point. So I do this, I do this here, I do then like I push like the BFS in front, where you have entered, where you have left. So each cell should have enter at some point. So what is the DP here? DP is, let's say, 0 here. I have something like this in this cell, then this makes it 1 length. And if I have something like this, then this makes it 2. If I have something like this, in your case, this would make it. No, I don't think this is possible because now what is this? Is it 2 or is it 3? Because if I go like this and this and this, it will be 3. If I go like this and count 1 here, this would be 2. What is this? It's not defined. So I think I'm not supposed to do that, but I'm supposed to just say that this is 2. And let's consider that this is 2, and let's consider then that that's like, let's say 3. And then you have something, let's say that 4, and then you have something. Let's say you have something like this, and let's say you have, well, there cannot be loops like this, right? So, I mean, I think it's just like you're pushing BFS over the cells here, and you're kind of saying, okay, this, and then I don't think loops are even possible here. Why wouldn't it? Well, because it won't be possible, because if you do this, you don't know what do you count 1 or do you count 2, and because this is a segment itself, this is one segment, this is one segment. This is not a segment. Doesn't make sense this to be a segment. Yeah, it should be I mean, I don't see a way, like there can be a way how to handle something like this as well, but the loops make it impossible. I would assume it's like well, I mean, I don't know. I don't know. It's weird how they didn't write this in the statement, right? This is the first thing you would ask yourself, like, wait, let me see an edge case where something will fail, right? And this is immediately something that comes to mind, because this is the only point where you would create loops. Because if you enter something here and something here, you can never enter again here or here. You would never create a loop. So you would just, so it's essentially what you're doing is like you're mapping each of these what you're doing is just creating a graph, right? You're just creating a graph, and then you know like the lengths of this graph of like all of these rows. You already know the lengths of them. And then when you know the lengths of them, now the question is, okay, I can calculate P1, I can calculate P2, right? Easily. I mean, just maybe a little bit implementation will have it, but I think I can call it. But P3 now it's the graph changes, and the graph that changes will affect only two paths. But it should have been explained better. Yes, I totally agree. I totally agree. It should be explained better. This is their fault. I mean, I don't like problems which do not like when you're writing a problem. You may consider something like okay. You may consider okay. This will be very well known, right? But you have to explicitly write everything. You cannot just miss something. I understood the way I said if I understood it the correct way. I mean, I don't know if it's the correct. I may be wrong here, but if it's your way, if you're saying that this is the way, then I don't know how to solve it because this would create loops, and you would probably this is exponential time solving. Probably you will need to know for each of these where you have entered, where you have exited, and then there's 2 to the n power of this like little where you enter, where you exit. Because you can have like you can have the you can assume that the board can be like all of these um, the board can be all of these with all of tiles 3. And then the problem is that there's 2 to the n squared ways of how you can travel through the board, right? Because like I can enter here, but there's like I can travel like this. Right. I can travel like this. Then I can say, okay, I will go here, and then I will go here, and then I will go here, and then you see it's like all a mess, total mess. You can just forget about it. But with my approach, what you will do is just you would connect these in a path, and then from here there's no way to access something like this. So there's like one path here, there's one path here, there's one path here, so there's no way. That's the edge case that made me move from the problem. Yeah. I mean, yeah, but I think they avoid something like this by just saying that this is a segment and this is a segment, and then you avoid all of these loops, you avoid everything. Now the problem is okay. You have something like this, but when I change a tile from this tile to something else, I affect two paths. Only two paths can be affected by this. So I can brute force through every tile and see if like one path where that one path is and how it like affects it with the other path. And then I can say, okay, so this path joins this path here, this path joins this path instead of like what it was previously. So because of this one flip, there will be different lengths, and then I think I can calculate even P3. It is a little bit implementationally heavy, but it is possible. Maybe I don't know. My stream is already running for what? For 3 hours. I think this is a good problem for another stream, like, but just only this problem, solving only this problem. But I have to ask first Martin if I'm correct what I said about this, because if I'm not correct, then I don't know what's the solution. But if that's the solution, you just count the paths and like you just, I mean, you just kind of And there are not that many valid paths actually. I mean, some paths are valid, some are not, because they don't end up. Yeah, that's really important. Yeah. So I think this problem I will solve in another stream because now it's already been 3 hours. But I like this problem. I mean I like that it's okay. This I have no idea. I have to ask about this problem. I have to ask about this problem. However, the other problem as well. If we solve these ropes, we may want to solve the other the problem too as well. Magic. This convex whole idea of like just, well, it's not gonna be like that difficult because like you have like, well, I think I can maybe call it even now, but I'm too tired. Like it's not that difficult because what you do is just like you're just pre-computing once and pre-computing twice and then just binary searching it. It's not that difficult. So where was my convex hull? Yeah. So what you need to do is like what I said. These segments here. If I'm here at the ith point, uh, essentially I will never be here. I will be always like somewhere here, right? But doesn't matter. So I'm let's say here. Then I need to store like segments where this is the most. This is here. This line. Then this guy overtakes it, then this guy overtakes it. So I store all of these elements. If there's some point, if there's some ij that is like very, very high, this may overtake a couple of other j's like this. So this would just change the whole. This I will pop this out of the stack and I will pop this out of the stack. So they just have like a stack and mathematics just to how it overtakes it. Evaluate at this point whether myself or whether the other guy actually overtakes it. Like I don't know if I should call this one right now. Like if this guy overtakes it, then this guy just goes here, and then I go to how big the overtakes. And then well, I think I can call it. Should I call it? But there's no viewers. I would just maybe call it the next live stream. Maybe tomorrow we should do one. I don't know what's tomorrow. The 7th. Oh, I have so many lectures on the 7th. Maybe on the 8th. Because on the 9th and the 10th I have official CERTS competition, but I want to call this one at least. So maybe either tomorrow or either on the Friday I will call this one because I already know the solution. It won't take me more than probably 30 or 1 hour to call it. It won't be even that. But I want to get accepted full, so I want to at least like these two problems accepted full, and then this I don't know. I will ask Martin about the solution, and I will ask about the other problem as well. So yeah, that's cool. I mean, really cool Olympiad. I like it. I'm just disappointed that spells that problem spells is not was not on the. I mean, I don't know how it got through the judges. How that problem how did they thought that that problem actually was polynomially solvable? But however, let me just congratulate once more for to everyone here, and so the official standings are here. It's Andre, Simona, Muresan, our team here, and yeah, there are a lot of strong, uh, strong people here. So yeah, wait, what about the what problem? What problem? Spells is no polynomial time solution all for tasks. If that's what you're asking. So I don't know if you read this, but this is like the results. This is like the official results, and they put spells out of the competition, so spells doesn't count. And now the official results are totally different. Yeah, spells doesn't count because apparently there's no polynomial time solution for the problem. I don't know, like if something like matching or some. I just read the problem, but I didn't think a lot of it. But they thought probably that there's something greedy or. But what they discovered is that some contestants had better solutions than even the judges. So they put the so um, so they put the problem away, which makes the standings look totally different. I mean, totally different. It's not totally different, but still, one problem could mean that. Um, what did you probably did? What was the problem about? I mean, I'm not sure what was the problem about. Like it's I read it, but where am I read it here. Like they want to make some matchings, but apparently you can't make this matching. Apparently it's like what is this template? Well, don't worry about it. It's just well, it's their mistake. Uh, it's interesting that I mean, what I wanted to mention is that uh, like it's interesting that the Olympiad happened in Strumica, my hometown, but I couldn't be there. So um, unfortunately, but I will try to solve the problems, and of course. So it seems like these two are very solvable, and then this is cool. Cool. Thank you so much for watching, for tuning in, and then I will see you these days. Then probably after tests there will be some stream or some new video on data structures, and we'll talk soon. Thank you, Blogger. Thank you again.